actually, who's done Git and GitHub before, or has tried or used in a project? I'm curious. How do you do this?
Should we like raise our hands? Okay.
Sure. Yeah. Sure, that's good. All right. All right, not many. All right, great. You're in the right place because we're going to be going over the basics of Git and GitHub. Git is this massive tool that it has a lot of depth to it and it's hard to master. So it's all right if you don't know what it is. It'll take time. All right, so here's our agenda for today. We're going to start with the history and why we need Git, and then we'll go over to what is version control, what the types of version control, and then we'll be going over some examples, how Git works, branching, and then plans for this year compared to last year. All right, this is an XKCD comic, which kind of is Git in a nutshell. It's not all like this, but it is funny. This sometimes happens, and yeah, it's interesting. Okay. All right, let's move on to about Git. So Git was created by Linus Torvalds. He's the creator of Linux in 2005. It came out of the Linux development community, so it was built for them to use on the Linux kernel. And there's 5 goals for Git. Speed has speed for large projects and small, all the same. It's simple. Well, simple does not mean easy. So it's simple in its core concepts, but it can get quite advanced sometimes. Support for nonlinear development, we'll get into that with branching. Fully distributed, we'll talk about that next. And able to handle large projects efficiently, which is great for the Linux kernel because that is a massive project. All right, so Git, pretty much God's name from one of these 3 things, you know. Git it wasn't named after anything explicitly, it was just kind of chosen. So, and from the last one here, you can tell that Git's actually, it's hard to use perfectly. All right, so before version control, why do we even need Git? Version control is a way, so before people were using version control, they were manually copying documents or code from one folder to another, and that's how they save, versions and stuff. It's common, but it's simplistic, but error prone, because if you miss a file, if you overwrite that file, if you lose that hard drive, all your work is gone. And so people created some version control software to fix these issues. All right, so is a version control system? And very simply, it helps manage software over time. So when you're creating a very software, you can use version control to keep track of every change you make. Let's say you break something in your project, you can easily look in your history and go back, which makes version control very nice to use. We use this in FRC sometimes. If we make a change and the robot doesn't work, we can simply go back and we don't need to spend hours debugging why. And yeah, this picture here, it shows a primitive version control system where all changes are saved on your computer locally as a database. And so this file here, it's been its history is being kept track of in this database. It's primitive because it's error prone. Again, if you lose the hard drive, you lose the entire files. You lose all your history, and only one person can work on it at one time. Also, I want to also say, if you guys have any questions whatsoever, doesn't matter what. If you want me to elaborate, go slower, go faster, put it in the chat. please, nothing stupid. You can say whatever you want, as long as it's not like distract. Anyway, so yeah, that's version control systems, also abbreviated VCS. All right, so centralized version control systems, they took the scene for a while. Git is not a centralized version control system, neither is it a local version control system. We'll talk about that in the next slide. So people, compared to local version control systems, centralized version control systems, where there are some multiple people could work on the same project at once. So the way it works is you can think of it kind of like a library, where each file can get checked in and out by users. If they check it out, they modify it, and then they check it back in, and it will store the history in the database. This was the standard for a while, and yeah, this little graphic shows you how each file is being used by a computer. All right, now instead of local, which was on the computer, or centralized, which was on a server, Git is a distributed version control system. So instead of on a central server, you're on the entire history of the project is cloned on every single computer you use to manage the source code. So yeah, each computer has an entire copy. Also a repo here where it says check in and out from local repo. It's simply that version database you see in that graphic. You can see here it says all the versions, and that is the repo. It's just that history file. It's really a directory, but it's, yeah. Operations are local. Instead of working with that server, you're working on your own computer, which is great because you can be away from internet, away from everything, and still work on the project. And when you get back, you can sync it with everyone else, which is really nice with Git. So that's what it means by operations are local. They are on your local computer. Any questions in the chat? This is a big one, so I'll make sure you guys understand it. I don't see anything. Okay. Cool. All right. So the basic Git workflow. So each file will first be untracked. So every file that you create in a new Git repository will be untracked. And what that means is by untracked is the Git does not keep track of it at all. It's just there. So first we do something called adding the file, which just tells Git that we want to save it. So you can see here first we have the untracked file and we add it. And so now it's in staged. And staging is simply a staging. You can think of it as like a mark to Git telling you that it's going to be saved in the next like snapshot, I guess, each time you save it. So it's just a way to tell Git I want to save this file. So first we tell Git that we want to track it, and then it becomes unmodified, and that just means that Git is tracking it, but nothing's changed yet. And so we edit it and we make it modified. Now, and Git sees that's modified, but it's not going to do anything with it yet. Next, we stage it, and with staging, you mark it, like I said previous, you mark it to be saved. And then once you stage it, you commit it. And then when you commit it, it's saved to the database. It's all nice tucked away in the database, and we don't need to worry about it. Any work that's in the database is very hard to get out. So it's pretty much permanent. There are some cases you can remove it, but it's pretty much permanent. So we commit it and it becomes unmodified again. and that we can just repeat that cycle every time we modify it. So yeah, that's the basic Git workflow. Anyone have any questions about that? Anything at all? No. Okay. If you're not understanding it or want me to elaborate or go over something again, please just put in the chat so I can go over something again. All right. I don't see anything. Okay. Oh, should we download something so we can start practicing it? Yes. So I will, so at the end of the presentation, there's some links there where you can go to the download page. Right now, I have it just on the slides, so you can see I'll go over some examples of how you use it. And yeah, I'll show you some resources so you can practice it after this. Yeah. And Jack, I have some examples on slide I'll show you. So yeah. All right, so next thing, checksums. Checksums are extremely important in Git. Checksums are how Git keeps track of each save or commit. So it takes what's called SHA-1 hash. And if you don't know what a hash is, you can just think of it as a unique identifier that will almost never be copied. It's pretty much really hard to copy. Every commit will have a unique SHA-1 hash or checksum. See here in the slide, those three things with 1677B, yeah, that thing. That is the first 7 characters of the hash, and usually that's pretty unique. A SHA-1 hash is a bit longer than that, but for Git we only see the first 7. And then after that is a commit message, which is a message describing on what you saved. And yeah, basically we refer everything not by name, but by hash. It's just an identifier for each commit. All right, next slide. GitHub. GitHub acts as a server computer in this little diagram. It's an online storage of Git repos. It allows for, GitHub adds some also extra layers to things that I'll show you guys later. But right now, all you can think about is it just syncs that database. And it's a way for FRC, for us, it's how we communicate between the computers. We go through GitHub. So we sync it to GitHub, and then we sync it from GitHub to our local computer. And that's how we sync up with everyone else. Any questions on that? Oh. All right. So that's GitHub. So now let's go over some not examples. Let's see how we actually use Git. A lot of people, they use the CLI or the command line interface. And wow, that got messed up. The desktop GUI. It's called, so here it's called GitHub Desktop. On the right, it's a nice graphical version of Git that shows you each commit on the left and all the changes. It's a nice thing to start out with if you don't fully comprehend all the commands yet, and it's nice to get in the flow of it. But I would highly suggest learning the CLI because it allows you to do many things that the GitHub Desktop cannot do. And even if you use GitHub Desktop, odds are you're gonna have to use the CLI one day because you want to do something that the GUI cannot. So for the rest of the presentation, I'm just gonna be focusing on the CLI, the command line interface. All right. So let's go over actually creating one of these Git repos. So Git makes it super easy to create a brand new one. You just do the commands git, which is going to be the common for all Git commands. It just tells the computer you want to use Git, space, init, and that's it. And that will create a brand new Git repo in your current directory. And this will do, this will create a .git directory, which is hidden in, in most CLIs, so you don't really see it. But so you can't really see it, but it will. But that's what keeps track of all the database stuff. So it's called .git, and don't delete it because that contains all the history. And you can commit files in that directory. And yeah. And then we can also clone a remote repo. And that's what we'll be doing if you're going to be doing this for robotics. We're going to clone a repo on GitHub onto your computer. And then that will create a basically just copy of what we have set in GitHub. So we'll be using the clone command, but if you want to practice, I would use the init because that's very simple and easy to work with. All right, here are the commands. A lot of these you don't need and we don't use majorly. Clone and so clone and init here at the init's at the bottom. Those are the two ones that you're going to start out with, but you don't really use those that often. Add and commit, the lines 2 and 3. Those we use a ton. That is definitely going to be a big point. We're definitely going to use those a lot. Get status is a very useful command. I also use that a lot. It tells you what's happening in the Git directory. Get diff sometimes you use that, sometimes you don't. It just depends. I won't be going over what get diff does, but there's some documentation on the Git website. Get help and then command, that'll show you the help page. And in current versions, it opens a nice HTML on your web browser, so it's really nice. And pull and push, that's how you sync with GitHub. You either pull from it into your local computer or you push from your computer to GitHub. And so those are really useful too. All right, so here's a simple example. And if you guys have a question why something is, or just ask in chat again. All right, so first thing we did, we created a new Git repository, right? We just created one in this /FRC folder. And you see, ignore the little master thing for now. We'll get back to it later, but just ignore it for now. So if we do status, we see there's no commits and there's nothing to commit. So we need to create a file. So I created a file called hello-world.java. And see here, there it is. We have hello-world.java. ls, that will display that's not a git command, that's just Linux. That just shows what files are currently in there. So git status, you can see that we have indeed added this file, but it's untracked, which means that we have not told Git about this file yet. So, and there's a little nice help message saying git add to track. So let's do that. We added it. You can ignore those, that weird LF will be replaced by CRLF. That's some weird Windows stuff, but that doesn't matter too much. We can see here in the git status though, that now, since we've added it, it says changes to be committed. That's in what's called the staging area. That's where we're getting ready to save those files to the repo. So once we do that, we can commit it. And that -n, and then that's the message I want to say. So that just describes what this commit does. So I added hello world.java. And you can see here that there's your 7-character SHA-1 hash. So master root commit, and then there's your SHA-1 hash, and then the message added hello world.java. And it'll give you a summary of what happened, you know, how many files changed, what, and 5 insertions. That's 5 lines I add to the file. And if we look at git status, this is your happy place. Nothing to commit, working directory clean. That means everything's been saved. Nothing's going to go wrong. Yeah, so that is what you want to see after you're done working. All right, next slide, we're going to talk about branching. And branching is this really cool little feature that Git is very, very, it's a big part of Git. And it's basically, if you guys know what pointers are, they're a pointer to a specific commit. But you can also think of pointers as a label. Oh, which one's it stuck on?
It says it's stuck on the introduction to Git in GitHub.
Oh.
Not sure why it's like that.
Is that also by everyone? Can everyone?
Mine is showing branching. Mine is okay.
Mine's on
Okay.
branching. I'm on branching.
I think you might have taken control accidentally.
Oh, where'd it go?
First one.
Huh.
Mine was also silent, or was.
Where'd it go? Let me try resharing it. Upload this presentation. Replace it. Okay. All right, what slide were we on? We were on 26. I just skip? No, I have to go through all of them. All right. All right. Does anyone see? Oh, Calvin. Huh. It's weird. Let's see. Okay. Let's see. I can upload the presentation to the software channel here. It's on the Files tab. You can follow along with that. All right. Yep, no problem. All right, so branching. Branching is a pointer or a label to a specific commit. So you can each one of these circles in this graph are commits or saves. So we point this little feature branch to this one and that master to there. It's very lightweight. Labels don't cost much. So compared to some other version control systems, which copy the entire file the entire history to a new branch, and it allows you some flexibility before adding to the master code base. So what that means is like if we are working on a project on a piece of code and we don't want other people to use it yet, we put it in a branch and then we work on it and then we can merge it back into the master. And that's just a little playground for you to tinker around in. So that's what branches allow you to do. So yeah. And they allow you to branch off the main code base to another area where you can work on your code. Does anyone have any questions? All are masters of branches now. All right. I don't see any questions, so I assume that everyone's good. We'll go over an example, so if you're a little confused, don't worry. All right, here's some quick examples of branching. So this is, again, the CLI, and to the right, there's a little graph. Oh. Okay, communication is really important, so we're not working on the same features. See, communication is a huge part because since we can't all work on the same code at once, we're going to have to split off eventually. And branching allows you to do that. So the communication is what we make and when we make it. So if we branch off before we have all the dependencies for that code, like if we need vision stuff to work on a teleop thing, then we need to make sure we have that before we start branching off to work on our code. So communication's a big part, especially in planning when we should branch off. That's a big one. So we're not gonna all be working on the same features, but communication is still a big thing. So back to this graph here. We see a commit 0 and commit 1. Those are C0 and C1. And we have the master branch and the 10-ball auto branch. So the master branch and 10-ball auto right now are pointing all to the same branch or same commit. So different branches, same commit. And that little star shows you on the graph, shows you what branch we're currently on. And on the left here, you can see that those little parentheses in the master, that is what branch we're on. So right now we're still in the master branch. So let's go through the commands. So git branch, and then we created a new branch called 10-ball auto. And then we're listing the branches with this git branch command. And we see we have 2 branches, but we're only on master right now. So let's go into the 10-ball auto branch. So we can do git checkout 10-ball auto, and that will switch us to the 10-ball auto branch. So now we're working on a different branch. And you can see that little blue label changed accordingly. Touch, don't worry about touch, it just creates a blank file. So I added a blank file, I added it. So we're currently where it's in the staging area, and then we committed it to this new branch. And you see here, we advance the 10-ball auto branch without advancing the master branch. So this is the basics of branching. If we could merge it back into master at this point after making our changes, the blank file, and then we could be all into one branch again. But for clarity, I'm going to switch back. If we switch back into the master and we make another commit, the graph would look like this. The 10-ball and master have diverged, and now we can. And so, yeah, that's how it works. Any questions on that? Anything I need to go over again? Anyone confused on how branching works? How splitting off and split off into a new branch, and then later we can merge it back in. I'm not going to go over merges right now because it's called, memorize these commands. No, I just want to get you a feel for these commands. Generally, what does add do? What does commit do? Like everything, we have a cheat sheet. There's a link to it at the end of the presentation. You're probably gonna be referring to a cheat sheet a lot, but that's fine. Everyone does. Yeah. So don't think you have to memorize these commands. I just want you to get a general feel for these commands, so you know kind of what you're doing with each of these commands. And Git takes a ton of practice, so don't worry about it. You're not going to get the first try, but yeah, Git is this huge thing, so don't even worry about it. We can work on it. All right, so what we did last year. Last year, we branched in the beginning of the year. So we created all these different branches in the beginning of the year to work on each of our own separate things. So we created an intake branch. Yeah, what Rohan said. You'll start to memorize them, but we have the cheat sheet in the meantime. So yeah, we created all these branches in the very beginning of the year or mid-year, and we so each person went to their own. Everyone was assigned a thing, intake, cargo feeder, and we worked in that branch for almost the entire year. And this was not the best for multiple reasons. First, since we branched all at the beginning, we had almost no code in the beginning, which means that, let's say if intake needed Vision's code or Limelight code, they couldn't do that because they're on different branches. So we had to copy and paste in order to, so copy from Limelight, put it into intake, and then you can use intake with Limelight stuff, which isn't the best for multiple reasons. It muddies everything up. You know, you don't know what something came from. And plus, if let's say Limelight needs they make a change, then intake doesn't have that change. So obviously it's not the best for those reasons. Branch is more of a prototype area. We tested intake in this branch, and then we copy and pasted the code into the main branch for competition. So it's not the best. It semi-worked last year, but for this year, here's the current plan. We're going to be using something called GitHub Flow, which is this great workflow that will strengthen team communication. And yeah, it's a lightweight branch-based workflow that supports teams where projects for deployments are regularly made. So since we constantly test, we have constant deployments. And also the master branch will be the most stable, up-to-date version we have of our code, which allows our drivers to use the best code that we currently have. So GitHub Flow, let me go over each of the steps of GitHub Flow. So the first step, lightweight. What do you mean by lightweight? So lightweight means that it doesn't take a huge amount of power to use this. So, okay, let me give an example. If we want to create a feature, for example, you'll see later how we do that, but instead of using all these complicated processes, it's lightweight. So lightweight just means it doesn't take a ton of processing power. You don't need to copy the entire GitHub repo. You can do it quickly and easily. That's pretty much what lightweight means. All right, so let's go over GitHub Flow. So the first step is branching. And also this little graph here I stole from github.com. They have a great documentation on this. I'll put a link at the end so you can check it out yourself, but I'll go over the basics here. So branching. First, we branch, and we want to branch, and every single feature or update to the code base that you want to make, you make a branch. And since we'll probably be protecting master, which means you can't make direct commits to master. So in order to get any changes onto the master branch, the main code base, you're gonna have to branch out, and that's for good reasons. So when we're working on a project, we have a bunch of different features and ideas, and or some ideas that are in progress, some that are ready to go. But branching helps manage this and break into multiple chunks. Changes they make on a branch don't affect the main branch. So you can experiment and do whatever you want in the branch, and it won't be merged. Your branch won't be merged until some people have reviewed it and make sure it's okay. Just make sure when you're branching out that you have all the code you need. And there's only one rule when branching out and merging back in, is that whatever's in the master branch has to be deployable. So it has to be in a working state. And that just allows easy for drivers and anyone that wants to branch to have a working copy of the code to experiment with. The next step is committing, and this is simple. It's simply adding your changes. So what do you want to do? You add, vision, you do whatever you want. Whenever you add, edit, or delete a file, you're making a commit. And so it's just, so you're, this process keeps track of your progress as you work on a branch. They also create a transparent history that others can follow. So they can see, oh, you did this and then you did this, and then you did this. So it's easy to see what you've done. And each commit has a message, so you can see exactly what's done and why. Furthermore, each commit is a separate unit of change. So you should be able to roll back and change what happened in that commit. And so, yeah. And it allows you to roll back if there's a bug or if you want to head in a different direction than what you intended to. So after you added commits, you create a pull request. And this is on GitHub. It's actually not native to Git. And a pull request initiates discussion about your commits. So even though they're not part of Git, they're deeply integrated with it. So it will show all your commits. And you can have conversation about those commits. And anyone, if they open up your pull request, can see exactly what would be put onto the master code base if they accepted the pull request. And the pull request can be opened at any time. It doesn't have to be when you're finished or when you're ready to deploy. You can open it at any time, like if you want to share some general ideas, or when you're stuck and you need some help, or when you're ready, or when you are done and you want someone to review your work. It enables more communication and should help us create better code that goes on the robot. Okay, the next part is discussion and review your code. So once it's been opened, you can ask, or people can check out your code, make sure everything looks good. We might have some changes, questions, or comments, and I highly recommend that everyone reviews the code, or as many people as we can get, because the more reviewed, the better the code will be. So maybe the code has a bug, maybe it just needs to be tested, or maybe everything looks great and they approved it. At any time, you can commit more, you can push more commits to your branch. So if someone says, oh, you need to add for this edge case, and they're like, oh, I haven't thought about that, you would push your commit, and then they can see, oh, you updated it. Let's see what you updated. Oh yeah, you changed it. All right, I'll change that to approve. So yeah, it allows a lot of transparency. Now this part is not necessarily all about that. We won't be necessarily using all of this. It's called deploy. And here, but for FRC, we just make sure everything runs smoothly. We'll test it on the robot, make sure everything works that you intended it to. Here we could add continuous integration if you know what that is. But I'm not going to get into that, but we could add it here. All right, and then the last step is merge. And here we make, now that it's all tested and working, people have approved it, and you're all good to go, we merge it into the master branch. And yeah, and then that becomes the master code branch. And the pull request and all this branch, the branch gets deleted, but the pull request stays. So we can see exactly, what happened. If we want to go back and say, hey, what caused that change? We can go back, see, oh, okay, it was created by this person because of this, because this person said that. So it allows a lot of transparency in the history. So in order for it to be merged, it needs to be approved by at least 2 people, and everyone who requested changes is satisfied. So if anyone's everyone needs, if someone needs to request a change, they need to make sure the system won't let them merge it until that person is satisfied by their request. Their request is satisfied. So that is all of GitHub Flow. Any questions? Any confusion on what each of the steps are, or how we'd handle a case, or anything like that? All right, I don't see anything in the chat, so I think we're good. All right, and that's the end of this presentation. Here are some resources to learn more. Git is very rich, which means there's a ton you can do. This was just the introduction, so there's gonna be a lot more things you probably are going to do. But here's some resources. There's the Git website, git-scm, for downloads and documentation. What's the correct way to work in the beginning? Okay, so the way we work in the beginning is instead of creating all those branches at once, we're going to create feature branches. So we're going to create one branch that's like, I don't know, add drivetrain, add the robot so the robot can move. We're going to make a branch called that. We make sure it goes through the process, and then we merge it as soon as it's ready. And so that process, instead of keeping those branches open for the entire season, we keep the branch open for less than a week. And that just allows the code to, all the code goes into the master and has quality. And so, yeah, that's the correct way to do that. Yeah. So ProGit, the second link here. It's a long book. It's like 521 pages. You're never gonna need all that. It's an interesting, some parts are interesting. It talks a lot about how like the more complex ways Git works, but it's also a great place to, the introduction's a good place to read if you're still wondering about something. And then this GitHub guide, that was what I just went over. You can review it, you know, make sure you have everything. You have the concept down. In this branching tutorial, this is an amazing branching tutorial. If you're wondering about branches, or you're wondering how to use branches, or how to, you know, create a branch, merge it, anything like that, this branching tutorial is great. It's in your browser. I highly recommend it. And then this cheat sheet back here, down here, this is GitHub's cheat sheet. It's a pretty good one. Yeah, that you're gonna refer to cheat sheets a lot, but you can find these easy on Google just by typing up Git cheat sheet. So, yeah. Any questions? Any more questions? Anything at all? Doesn't have to be anything. Anyone confused about anything still? Everyone got this? These links are posted. They're not posted. They're on the. I guess I could post them somewhere.
Yeah, if you want, you can just make a new like topic in software and put all the links there.
Sure, sounds good.
Afterwards, yeah.
Yeah, I will do that afterwards. Jack also said that you can search for it directly as well, so that works too. Yeah, that's the end of this presentation. So.